Alright, so let's look at some problems to help us review for our Module 8 quiz. So, we are going to be looking for the sine of angle theta, the cosine of angle theta, the tangent of angle theta, the cosecant of angle theta, the secant of angle theta, and the cotangent of angle theta. Now all these have known relationships of the sides of a triangle, opposite, hypotenuse, and adjacent. So we'll have to go over here and find what those sides are. So first I'm going to find the missing side. And I know I can do that using Pythagorean theorem. So this side is the hypotenuse to 15. So when I do my a squared plus b squared equals c squared, I know I want the c to be the 15. So we'll call the a the 13. So 13 squared plus b squared equals 200, or 15 squared, which will be 225. But we'll just write 15 squared for now. So when I square these, 13 squared is 169 plus b squared equals 15 squared, which is 225. I'll subtract the 169 from both sides. So b squared is going to equal 56. Taking the square root, b is going to equal the square root of 56. Now if I break 56 down, we know that is going to be 14 and 4, 2 and 2, 2 and 7. So I have a group of 2's that come out. So I could write this as 2. And then I have a 2 and a 7 left inside, so that'd be 14. So this missing side over here would be 2 square root 14. So now we just have to figure out what side is which. Well, we know this is the hypotenuse. We said that earlier. This side across from theta, so this one would be the opposite, this 2 radical 14. And this would be the adjacent. So now we just write that in our ratios. So the sine is the opposite over the hypotenuse. So that would be 2 square root of 14 over 15. The cosine is the adjacent over the hypotenuse. So that's just simply 13 over 15. And the tangent is the opposite over the adjacent. So 2 square root 14 over 13. Now to find the other ones, really all I have to do is flip them over. So the cosecant is the flip of sine. It's hypotenuse over opposite. So it's 15 over 2 square root 14. The secant would be the flip of cosine, so that's 15 over 13. And cotangent would be the flip of tangent, so that's 13 over 2 square root 14. So all I had to do is use my Pythagorean theorem and then find out which side in our triangle was the opposite and the hypotenuse and the adjacent, and then plug them in. Okay, let's look at problem number 2. It says, given the cosine of A equals 1/7, find the value of cotangent A. This is really a problem that's just like the one above, only there's no triangle drawn, so we're going to draw our own triangle. So I'm going to draw a right triangle with an angle of A in the corner. Now it says the cosine of A is 1/7. Well, we know the cosine is the adjacent divided by the hypotenuse. That's a known thing. Cosine of some angle is adjacent over the hypotenuse. Well, since the adjacent in this case would be 1 and the hypotenuse is 7 because that's on the bottom, we can fill that in the triangle. So the hypotenuse would be 7. And the adjacent side, since this is the opposite of angle A, this must be the adjacent, so this is 1. So now the cotangent of the angle is the adjacent over the opposite. So far we know this is the hypotenuse and this is the adjacent. but we don't know the opposite side. So again, we'll have to use Pythagorean theorem to find that missing side. So if we do that, so we know 7 squared equals a squared plus b squared, which is 1 squared. So that'd be 49 equals a squared plus 1. Subtract 1, I get 48 equals a squared. So take the square root, so that's square root of 48, or if I simplify that, that's 4 square root of 3. You can simplify that just like we did in the problem above, where you break it down and factor it, but it would be 4 square root of 3. So now, since we want the cotangent, that's the adjacent side, which is 1, divided by the opposite side, which is 4 square root of 3. So giving the cosine, we found the value of the cotangent. All right, let's look at question 3. Question 3 says, find the missing side length here. So we're trying to find this x. So we have this angle of 49. So if you look at this triangle, we know that this side across is the opposite. This side is, of course, the adjacent, and this is the hypotenuse. So really, we're dealing with the opposite and adjacent sides, because one has the number and one has the side we want. So if we look at our ratios, the one that does opposite and adjacent is the tangent. So we know the tangent of 49 is going to equal to the opposite, which is 14, over the adjacent, which is x. Now, tangent of 49 is just some number. We can just put it in the calculator. Tan 49 is going to give us 1.15. So, all right, this is 1.15 over 1 equals 14 over x. So I can cross multiply. 1 times 14 is 14. And 1.15 times x is 1.15x. And so I'll simply divide both sides by 1.15. So x is going to equal 14 divided by 1.15, which is going to give us 12.17. So that is the missing side. So all we got to do is set up our ratio and solve for it. All right, number 4 says solve the equation sine x equals the square root of 5 over 12. So what we're truly trying to find here is we're trying to find this x value, which is kind of the angle. We want to know sine of what angle equals this weird number. Well, this is actually probably the easiest problem to do, because all we have to do is to find the angle. We will take the inverse trig function of the ratio. So by taking the inverse sine of radical 5 over 12, we can figure out what angle that is. So I'm just going to type that in the calculator. If you are doing Desmos or something, make sure you have it in degree mode. But what I get is x is going to be 10.74-ish degrees. So I can check it because I know the sine of 10.74 degrees will give me square root of 5 over 12. All right, number 5, we're going to again use that kind of inverse trig operation because we're trying to find this angle. So if we look at this triangle, we have a right triangle that has a hypotenuse of 20. It has an opposite side, which we really don't know. And so that means this 13 is the adjacent side. So hypotenuse and adjacent would be the cosine ratio. Because if you look at all our trig ratios, the one that has those two is the cosine. So we have cosine of this mystery angle. I'll call it angle y. It doesn't matter. So cosine of this mystery angle y, where the question mark is equal to 13 over 20. So just like the problem before, if I want to find this angle y, I will take the inverse cosine of 13 over 20. And what that will do is that will find my angle. So the inverse cosine of 13 over 20 is going to give me 49.5 degrees. So that would be this angle here. Again, just make sure that your calculator is in degree mode. When you're finding the angle, use the inverse. If you're not, you just use the regular and set up your proportion. Let's look at number 6. 6 is a problem from section 8.3 where we had all these different exact values. So really all I have to do is look at my chart to see what some of these values are. For example, the cosine of 30 is the square root of 3 over 2. And you can refer to your notes for that chart and how we got all these exact values using those special right triangles. The cosecant of 45 is the square root of 2 minus the square root of 45, which is square root of 2 over 2. So if we multiply, we can multiply these first two because this is like square root of 2 over 1. So if I multiply square root of 3 times square root of 2, I get square root of 6 over 2 times 1, which is 2, minus the square root of 2 over 2. So since they have the bottoms, if we'd like, we can write them together. We cannot subtract those radicals because they're not the like radicands, but we can subtract them and write them together like so. So that's the exact value of the cosine 30 times the cosecant of 45 minus the sine of 45. So again, most of those just came from our table that we had in our chart. So problem 7 says, graph the angle 520 degrees in standard position and state what quadrant the angle would lie in. So standard position means we're going to graph it on the XY plane with our initial side pointing this direction. Now it's a positive angle, so we're going to rotate counterclockwise. So we'll start by going up, and we're going to go 560 degrees. Now I know I'm going to go at least a full turn because that's 360 degrees. A full circle turn is 360. So if I do that, I have 160 left to go. So there's 90 more, so that's going to leave me 70 more to go. So I'm going to go to about here. So this is my 520 degree angle. I went around a full turn and then another 160, which is going to equal my total of 520. So when it says what quadrant does the angle lie in this case it lands in quadrant 2. Because if you recall, the quadrants go 1, 2, 3, and 4. So this angle ends up in quadrant 2, so that's why we say it lies in quadrant 2. Okay, number 8 says find the value of the cosecant of pi over 6. Now pi over 6 is a radian measure, and if we look at our chart, everything is in degrees. So the first thing I'm going to do is I'm going to convert this to degrees. So anything that's in radians, I'm going to take, and to go to degrees, I'm going to multiply by 180 degrees over pi. So these pi's will cancel, so this really turns into 180 divided by 6, which is 30 degrees. So the cosecant of pi over 6, this radian measure, is really just asking for what's the cosecant of 30 degrees. So if I look at my chart and I look for what's the cosecant of 30 degrees, that would be 2. Okay, last problem. What is the radian measure of 1050? So again, when we're trying to go from degrees to radians, we're going to multiply by the opposite. It's going to be pi over 180. So I'm going to take 1050 times pi over 180. And I'm simply going to simplify the fraction 1050 over 180 and add a pi on it. So that would be, I can cancel the 10, so that would be 105 over 18 pi, because I just basically canceled the 0 from top and bottom. And so now I'm going to think, is there anything that divides into 18 and 105? So you can reduce the fraction in your calculator, or I know 105 and 18 both divide by 3. So 105 divided by 3 would be 35. 18 divided by 3 would be 6, and a pi. So 35 over 6 pi. Now honestly, if you would have put this 1050 over 180 in the calculator, it would have reduced the fraction right away to give us this 35 over 6 and add the pi. But not too hard to reduce fractions. Alright, so there's just a couple quick problems to review for quiz 8. Let us please know if you have any questions.